Okay, so I hope my screen is visible to you and I'm audible to you. So I'm Kamna Mishra from IIT Mandi and I'm currently doing PhD in statistics. And this is week 12 of problem solving session of probability and statistics. And this course is instructed by Professor Sumesh Kumar from IIT Kharagpur. So in the last class also we have gone through uh, I think the alpha and beta, like type 1 and type 2 error in the time of hypothesis testing. So, firstly, I have introduced why what is the need of this hypothesis testing and why do we perform this. Now, in the today's class, we will go through the things like how do we take this hypothesis test. Like if you have let's say your mean is known and then you want to test for the variance, so this can be the one case. And another case is like sample for sample. If you have one sample, you know its mean and variance you can find. But for the population, it may happen whether your mean is known, you are testing for variance, and it may happen your variance is known and you are testing for mean, and then maybe both are known, and then you are checking how good your sample is, whether you need to accept it or reject it. So there can be various kind of testings, and for all the tests there are different formulae, so that you need to go through also. And okay, so I'm gonna start the class with the hypothesis testing. Like we have so many questions based on this. So firstly, I will just give some, let's say, some formulae that we will use, and so that you can recall also. And when we solve the questions, you will like remember, and you will maybe guess like which are the formula we need to use here, so that you will just understand with examples and all. Okay, so sorry for that. Okay, yes. So now there can be several cases. So if you go through the classes Sir has taken, I think there are different hypothesis testings. So I'm gonna go through just in a summary kind of thing because there is not much time. So okay. So now there can be like testing for what? Let's say we are doing testing for mean mu, right? So what we are doing here is that, let's say we have a population which is normally distributed over mean mu and variance sigma square. Now what can happen is that first there can be like sigma square is known, and another thing it may happen is that the sigma square is not known, right? So if we take sigma square is known, and then we can take whether it is like, then we can simply, what we can do is that we can convert it into the standard form, and then we can take its standard form. Now in the time of testing, what is one important thing about the sample? Does anybody know? Like if a sample size is this, then we should perform this test, or if sample size is this, then we should perform the other test. Like, do you have any idea? that how sample size is related to the testing we are going to use to find this mean. Okay, you can. Okay, you don't know. So what happens is that you always have this thing that t test. If you have t test, okay, now you can mute yourself. I think. Okay, so if you have any sample size which is let's say less than 30, okay, so at that point of time we generally use this t-test, okay, but if sample size is greater than 30 then we take z-test, and in t-test we use also the degree of freedom, whereas in z-test we do not use any degree of freedom, so we say that if n is greater than 30, so in any distribution we say that most probably that this x bar that we say standardized form will follow this normal distribution, and then we take this z test. Okay, so now if you have this h, you last class also I have told you that z h, sorry, h naught we can take in different forms, so we can take it is like mu is equal to mu naught, and h1 we can take in three forms, like mu is not equal to mu naught, and mu is less than mu naught, less than less than mu naught, sorry. Mm. And then second we can take mu is greater than mu naught. So this one and this one will come under this one tail test, and this will come at two tail test. Now another thing we can take like h naught as mu is less than or equal to mu naught, and h1 is mu greater than mu naught. So there is one thing you can see that if there is something in h naught, it's not that h1 needs to be the complement exactly, right? Because this is the complement only. This is not complement, but that needs to be subset. So if you see that if you have h1 this area and h not this area, their intersection will should be zero. Okay, so if this is h naught and this is let's say h1, then it's fine, but this can also be h1, but this cannot be h1, okay, because there is one reason where both are intersecting. So if this is the reason we are getting any result, then we how do we say whether h naught is true or h1 is true? So this is like kind of doesn't work for our hypothesis. So that's how we make our hypothesis based on the uh, thing we need to do, like let's say number of accident in a road happening in one day, or if you go to like industrial area, then number of particles emitting in the environment for a particular thing, let's say. So whatsoever test you are performing, on the basis of that you will take h naught or h1, then what hypothesis you need to test here. Okay, so and this is we are calling as null hypothesis, and this we call as alternative hypothesis. So we say that we are rejecting h naught, we are rejecting h naught if root n x bar minus mu naught divided by sigma naught is greater than z alpha. What does it mean? It means firstly, we know that we write like this. If we have n sample, then we write z like this. So that you know, I think x bar minus mu divided by sigma upon root n is the number of sample. So this is our z. Okay. So what we are saying is that we reject the null hypothesis if z greater than z alpha, right? Why? Because this is our null hypothesis, right? So let's say up to this is our null hypothesis, and if we up to this is our null hypothesis, if we go beyond this, then we are rejecting this null hypothesis, because in that part h1 mu will be greater than mu naught, and if mu is greater than mu naught, that means alternative hypothesis is true, and that means the null hypothesis is rejected. So now you can see, if you have h naught as mu greater than mu naught and h1 is mu less than or equal to mu naught, then this test will be opposite. So it does not happen all the time that you have taken the value of z alpha and all the time you are saying this, if this is greater than z alpha, then we are rejecting the null hypothesis. So your null hypothesis will decide when you will reject it and when you will accept it. So firstly you need to go through this and then you will do this. Okay. And so if you do in this part, then it will be minus z alpha, because this part is minus z alpha, right? And okay, so here we have taken this case 1. Here sigma square was known. Okay, and now if we take this case 2, then and we are taking this sigma square is unknown. Okay. So then we can perform this t-test. So if sigma square is known, we are using this z-test, and if it is unknown, sorry, then we are performing this t-test. So now you know how to this this statistics as z. This we can also write in time of t. But since here sigma square was known, so we have taken sigma naught, like sigma naught is sigma square. So here we have taken sigma naught. But if it is not known, then what we will do? Then we will say this x bar minus mu s upon root 10, right? So in the above part, we have just taken this as sigma naught, but in the below part, we will take this as s, and s is the sample variance. So because we do not know the population variance, so this statistic we will call it as t, and then if we have the hypothesis like given above, that means this one, like this is mu is less than mu naught and here mu is greater than mu naught, then this t statistics will be rejected. So we will reject this above h naught if t is greater than t now n minus 1 comma alpha. So that's why I have said this n matters. So n here will be this, right? So n is the number of sample, and here you will take n minus 1 comma alpha. Okay. Now, now we will have another test, which will be the testing for the variance. Now there can be several tests. So you maybe okay. I don't know whether you know or not, but this one was for whether the mean of the sample is equal to or not the sorry, whether this mean of the sample is equal to the population mean or not. Now there can be another case is that we are taking two sample, and then whether we are checking this mean are equal or not, these mean are equal or not. Then at that point what we do is that we do mu1 minus mu2. Okay, so I don't know whether it is given or not. Yeah, it will be. So it will come under two sample problems. So this is for one sample. So firstly, we have checked for one sample whether one sample is working or not. Next, we also check sometimes with we are taking several number of samples, and then we say that one sample is mean is equal to the another sample mean or not, and its variance whether matches or not. So that most probably maybe we can do like if we have, let's say, population size is 1 lakh, and then we are taking sample size as 10,000 and let's say 5,000. So if mean and variance both are equal, then in the next time what we do is that, let's say, not just next time, we do generally several time its analysis, and we are checking that all the time the sample size, if we are decreasing by 5,000, if we are decreasing by 5, then also it's working for us. Then why do we take this 10,000? So there, this can be one reason for checking. So this course is basically theoretical, but I think if you understand this practical part, it will be more interesting also. So that time we can that test will be very useful. Like we are just decreasing the sample size by half, and then we are getting the same result. So it will be useful, right? So that time we can use this two sample problem. Okay. So now we what we have also this testing of variance. You can get all these things also in the third lecture. I'm not saying this, but this is like kind of summary. This is just a revision, and then if when you will go through the questions right now, maybe it will be good for you. So that's why just I'm repeating some things. Okay. So you know that when xi follows this normal mu sigma square, then mu sigma square, let's say, then we say that xi minus mu whole square summation, this follows this chi square with degree n. Okay, so this xi minus mu, this basically follows this chi square test. Like let's say xi follows n and it has some parameter, then xi square summation that will follow this chi square with degree whatsoever is I is there. Okay, now we can have this statistics. Let's say h naught is sigma naught is square, and then h1 is that mu naught. Now you can take it as h1 k1 anything. Just remember what is your null hypothesis and what is alternative. So for null, I prefer using 0. Um, there is no hard and fast rule to use this. Okay. So we say this, we represent this by W basically, this part by W. And then we say we reject this null hypothesis. We reject this H naught if W is greater than or equal to chi square and comma alpha. Right? And if we reverse this hypothesis, let's say h naught is greater than or equal to, and this is less than. So in time, if we reverse this hypothesis, then at that point of time, we say we are rejecting this if W is uh, greater than chi square, you know, this square is less than or equal to, less than or equal to this, and and then 1 minus alpha significance level. Okay, so this we perform when mean is known, and then if mean is not known, so in case of this, just wait, because you can see that we are using mean here. So if mean is known, then we can perform this hypothesis, whereas if mean is not known, then it's very simple. If mean is not known, then we just take w as n minus 1 s square by sigma naught square. Okay, and then rejecting just it will just change by n minus 1. Okay. So this is testing for variance, and then there is testing for proportion. So testing for proportion is same, like if you have this here, so if we are dealing with one side test, then we take z alpha. I have said most probably previously. If not, then if you have two tail test, let's say mu is equal to mu naught and mu is not equal to mu naught, at that point we take z alpha by 2. Okay, because what happens is that we are taking two side. Okay, so this and this, so alpha is given, then we take the test as at alpha by 2. Same case here also. And for the variance, for the variance also, so that we take alpha and alpha by 2 if we take two tail test. Okay, now if we take test for proportion, so proportion is nothing but let's say proportion. Okay, so proportion is nothing but you have, let's say, 500, and then you say like 400 student pass and 100 fail. So that 4 by 5, if you take this 400 by 500, it will be a proportion. This 400 and 500, this will be kind of proportion. So your test will go like this. So 500 minus 400, something like this. And if you check for the mean, what it will be? It will be, let's say, 1 minus this point 0.8. Let's say this. So there would be something, I'm saying this 500. So proportion is nothing but that is also in terms of mean you can treat. So its test would be very similar. So if you have here, let's say x bar minus mu, so what happens is that you will take p minus p naught. Okay, so p naught will be proportion because here both are mean, and in the division it will be pq divided by n. Okay, so maybe in regarding, I think binomial you can remember. So binomial, you have, if you have mean as p, and then variance will be pq upon n for the sample. So this you can take, right, like proportion. Okay, and then also it will depend if you are taking on uh, one tail test. So one tail test you will use z alpha. If you use two tail test, then you will take z alpha by 2. So it would be more clear when we will do questions, but this is just, I'm saying like this. Okay, and one more thing I wanted to tell you was two sample problem. Two sample problem. So two sample problem, if we have, let's say, so I will not go through the whole thing. I will just say how do we say this statistics. So basically in two sample problem we check whether the mean of both the sample is known or not. So then if mean is known, you know x bar minus y bar, and then if mean is known means minus mu1 minus mu2, right? Minus mu1 minus mu2, so that would be 0, right? So we simply say x bar minus y bar, and in the division sigma 1 is squared by m plus sigma 2 is squared by n. So this will be 0 when h naught is true. So this is we take hypothesis, and on the basis of z alpha or alpha by 2 we say whether it is true or not, right? So now there are many cases when it is known, when not known. So that we will see in the lecture. I think it will take otherwise so much time. Okay, so if you have any issue till now, you can ask. Just like this is kind of summary. If you have any issue on this, you can ask. Otherwise, we will start from the questions. Okay, okay, okay. So this is say our first question, and I want you to try this because I think we have just done similar one. So in I think yeah, we I think we just did this. So this is you can do. Okay. So what is given here is that you have given this null hypothesis and alternative hypothesis. So what is given, mu naught is greater than mu one. So h1 is given, mu is greater is equal to mu naught, and h2 is given, sorry, k1, this is alternative hypothesis, mu is equal to mu one, right? Now another thing is given, mu naught is greater than mu one. What it means is that k1 is given this. So k1 means given is mu less than mu naught. So this is basically your k1. So when we are rejecting this null hypothesis, when mu is less than mu naught. So when should we reject this null hypothesis? You can try it. Any guesses? Okay, so firstly, what is this test? Whether it is one side or two side sorry, one tail test or two tail test? Huh? One tail test, right? Now, it is one tail test. So that you know, in one tail test, you have alpha or alpha by two. Alpha. Okay, so A and D will be rejected firstly. So A and D would be wrong. So answer can be B or C. This can be answer only. So now what is given here is that rejection reason is when it is less than mu naught. Okay, so less than, that means here. So this would be the rejection reason, right? So let's say this. So rejection reason here. Okay, here rejection region means here if we have, then we take z alpha, and if it is here, then we take minus z alpha, right? So this would be the answer, because if it is less than this, if it is less than this, then mu will come here, right? If mu is less than mu naught, then it means it is coming under this k1. K1, if it is coming this under this k1, that means h1 is not true, so we are rejecting this h1. Simply, we reject this h1 when the answer is coming under this region. So, if this is less than z alpha, that time mu will be less than mu naught, and that time we reject this null hypothesis. So, this would be the answer. Any doubt? Okay. Okay. So, our next question is regarding this hypothesis testing, and sorry. So, just a minute. Regarding this hypothesis testing, what is given here is that that x bar is given. Sorry, x1, x2 up to xn is given, and what is given here is that, okay, so n is equal to 10, and this summation xi minus 2 square is equal to 30. And then what would be the decision? Okay, so firstly, h naught given here is that is sigma square less than or equal to 2, and then k1 is sigma square greater than, right? So what would be the decision of this hypothesis? So now you can see that here we are using this Sam, sorry, testing of hypothesis when mean, because mean is given, mean is equal to mu is equal to 2 is given, and then we are rejecting or accepting this hypothesis on the basis of uh, this sorry, on the basis of W is equal to sigma xi minus mu whole square divided by sigma square, and then uh, it is chi square n, right? So this is our hypothesis. Let me just write it. So now this value is already given as 30, so I'm just writing it xi minus mu naught whole square divided by sigma naught square. Okay, so sigma square we will take here as 2. So this value given here as 30, and this value is 2. So this is what, this is basically 15, right? So now we need to take this decision for this testing problem when alpha is equal to 0.05. Now you can see this is one tail test clearly. So at that point of time, I have just given here this test. I think this, yes, testing for variance. So this is similar, very similar, I think. So what we do is that we reject it when chi square n comma alpha. So now we need chi square table for this. Okay, so n given here is, I think, 9, right? Because this is 10, so n will be, n would be 9, and then 9 and 0.05. It is 16.919. So this is not clear maybe from your side, but this is this, I think. Maybe we have any other table. Okay, so that you can see at 9 degree of freedom, this is 16.919, right? So 16.919 is our chi-square. Now we can see that chi-square value is greater than this w. What does it mean? Whether we reject or accept? If we have chi-square value at 9, which is okay, sorry, we take at 10, so 10 would be, I think, much higher. So 10 would be 18, I think. Yes. So chi-square with 10 comma alpha, it would be 18 point something, and this w is star is less than this. Then what do you think? What should be this decision? Whether we can accept this null hypothesis or reject null hypothesis. Reject or accept? Reject? Okay. Okay, you're not sure. Let me go through this slide again. So when do we reject? We reject H naught. So H naught and H1 is same, right? Mu square H1 or K1 anyway. So this is same. This is various, and then we are rejecting when our W is greater than chi square. Okay. So W is our value and this is fixed value. So it is greater than. So we are rejecting this null hypothesis when it is greater than. I think the sign is a little bit not clear. Okay. So here it is not greater than. I think I have written this like this. That's why you're just confused. So here our W star we have found is less than chi square 10 comma alpha, right? So we will accept this hypothesis. Okay. Is it okay, or do I need to repeat? Okay. Right. Now the question is given if in the question 2 itself, okay, like in the last question, we are just taking n is equal to 8 and we are considering this value as 34, right? So w is what, this summation divided by sigma square, so that was 2, so it is what, 70, right? And then chi square 8 comma alpha 0.05, we will again check, right? So at 8 its value is 15.5. So now you again try whether this time we can accept this null hypothesis or not. So this time our chi is square value is less than w. That means the w we have found this time is greater than chi square. So when it is greater than chi square, then yeah. So that this time we will reject this null hypothesis. Now you can see how a very small change can uh, that just uh, have the different result. A very small changes can give the different results, right? Okay. So next we are going to have we have this question. We are taking what we are doing is that we are taking one random sample, okay, and it is given we are taking this random sample from the normal population and it has this values, these many values, right? And here you can see that mean of the population is given and mean of the population is 10 against this hypothesis. So mean of the population is not given here, right? Because we are just testing this hypothesis, right? So null hypothesis is what? Mu is equal to 10 and then alternative hypothesis is mu not equal to 10. Sorry, not equal to mu naught, which is equal to 10. That you can write maybe like this. So this is given, and then we want to find the value of value of test statistic, and its critical value at 5% level of significance. So now you can see this sample size is 10. So we will perform this t test. So n is equal to 10. Now t test, what I have said is, and also this mu is sigma is not given, so z test will not be performed because x bar minus mu divided by sigma upon root n, so sigma is not given. So anyway we will perform t test. So x bar minus mu s upon root n. Okay, now x bar that you need to find. So firstly we need to find x bar and then we need to find this s, right? Because that is required here. So n is 10 is given here, mu is 10. So x bar is x bar and then s sample size. So that I think I have told you, you can find in calculator also. Three is 10. Okay. This is 9.7, 2.67, 11.81, 7.89, 11.18, 10.13, 10.56, 5.43. Okay, so x bar is 11.155, and then 6 is 1.93. this is this will be 1.83. So around this. So that you can, I think, check how do we calculate this in calculator. You need to go through the mode and three in stats, and then you can put the values, all the values, and then there is option to find how to do this. So there must be tutorial in YouTube for that. So okay, now we have found this x bar and s, so that we can do minus 1.83 divided by sorry, minus mu was what, 10, and s is 1.83 divided by root n, which will be root 10. Okay, it will be, I think, 1.155 divided by 1.83 by root 10. Right, so this value is approximately 1.99. Okay, so t we have found is approximately 1.99. Right. Now you can see it is two-tailed test. Okay, so in the time of two-tailed test, we take alpha by 2, not alpha. So it would, so the test statistic will be performed at t alpha by 2 and n minus 1. So n minus 1 is 9. So now again we need this t table. Okay, so 9, and then we can see it is two-tail test 0.05. So for two-tail 0.05, we can take this 2.262. So this value is 2.262. Okay, and our t value is 1.99, which is less than 2.262. So then we will this reject this null hypothesis, right? So I think it would it is it would be this, because there can be some error in this calculation, so it is not coming as exact, but this is coming closer to this, and test statistics is 2.262. So this is not question here whether we will reject or not, but the answer is we will accept this null hypothesis, we will not reject it. Is it clear? So next question we have here is that we have a random sample of size 12, and then okay, so just n is equal to 12 is given, and then we have given this is taken from the normal population with mean mu and variance sigma square, and x bar and s square be the sample mean and sample variance. So t is given like this. Now, when do we, what is the test? When do we reject this null hypothesis? So it is, I think, very simple, that all you need to do is that you need to check at t at n is equal to 11, and then 1 minus, uh, sorry, not 1 minus alpha, at alpha by 2, right? So alpha by 2, 11, so at 11, right? You can see this is for two-tail test, and this is value is 2.201. So 2.201 is the value. So I'm telling you the answer can be C and D. Now you try when do we reject this null hypothesis. We have h naught as mu is equal to mu naught and h1 as mu not equal to mu naught, right? So this is the test statistic when do we reject this null hypothesis. Okay, why do we reject when it is less? Okay, so basic idea you need to understand what I'm saying. If you have this statistic, let's say for two tail, okay? So when do we reject if it comes under this region, right? So if it comes under, because this is Z, but when it comes under this region, what it means exactly, okay? You have this is your real mu, okay? Now there would be some deviation, right? Let's say this and this and this, right? So what do we say that we reject if it comes under this? Okay. So we can make it a small if it comes under this, if it comes under this. So at this portion we are accepting. So we reject when it is here or here, right? So that part is greater than always. Okay. So because this you are testing for this, or if you have this kind of test where you are testing for a left tail, okay, then you reject it at this point. uh, Sorry. And if you have tests like this, then you reject for this part. But if you have tests like this, then you can just treat always that it would be rejected when it is graded. Okay. So there can be some confusion in this and this that you will understand by time. But for this type of case, you can always assure that you will reject null hypothesis when it is greater. Okay. So for the future, you can just remember this. So if it is this kind, equal or not equal, then rejection will always be when it is on the greater side. So now we will move to the next question. So what is given here is that two machines we are utilizing to fill 12-ounce net volume plastic bottles, and this filling process can be assumed to be independently normally distributed with the means given here as mu1 and mu2, and the standard deviation given here as this sigma 1 and sigma 2. So we are performing this experiment and then we are taking this null hypothesis by taking this random sample of size 5, okay, and then from the output of each machine. Okay, so for the testing of hypothesis, now you can see is that sigma 1 and sigma 2 is given, so we can perform this z test. Okay, if it is not known, then we perform t test, right? So for the testing of hypothesis h naught mu 1 is equal to mu 2 and h naught mu 1 not equal to mu 2, we need to find the value of a statistic. Okay, so x bar and y bar we need to find. Let's say this is x and this is y. Okay, so uh, n- this is two sample problem as you can see. So h naught is what, mu1 and mu2. So z I have told you here in two sample problem, we what we do is that this is 0, so x bar minus mu bar divided by sigma 1 square by m plus sigma 2 square by n, right? So and m and n is also same, so that we can take out. So here z would be what, x bar minus y bar divided by sigma 1 square plus sigma 2 square and divided by n. So otherwise it is m or n, but here it is same. Okay, so this value we already know. So all we need to do is that we need to find x bar and y bar. So x bar would be 12.03, 12.89, 12.43, 12.32, 12.68. It is 12.47, and this is 11.92, 11.99, 11.78, 12.07, 12.23. So this is 11.998, right? So this now we can find the z. So z would be what? This value and then 12.47 minus 11.998 divided by this one is 5, right? 0.018 square plus 0.021 square, right? 12.47. Okay, so the answer is 38.158. Okay, so that is question here. So that would be the answer. Okay, but there is less chance that questions like this would come, because they will basically what do we do with finding of value of tested statistic? It does not make any use, right, until it does not give any kind of result. So at last we will see that whether it is coming under this critical region or not. Critical region means rejection region. So if it comes under the rejection region, so whether we can uh, take our null hypothesis to be true or not. Right. Okay. So now we will move to the next question, and the question here is we have this the burning times in minutes of the chemical flares of two different formulation are given, and then we need to test the hypothesis that two variances are equal. Now, to check two variances are equal, what do we have? We use F statistic. Okay, so firstly we will go through F statistic and then we will do this test. So to sample problem. Yes. So I can write this here only. variance testing in case of this mean is not known, right? So you have h naught as sigma 1 square is equal to sigma 2 square, and for 1 is per sample, this is for the second sample, and this one is sigma 1 square not equal to sigma 2 square. Then to check this hypothesis, we use f is equal to s1 square by s2 square, and then it follows f m minus 1 n minus 1. So if we reject this h naught, if f is greater than or equal to f m minus 1 n minus 1 comma alpha by 2, or we reject f is it is f m minus 1 n minus 1 1 minus alpha by 2. Why? Because if you have this same degree and you change alpha by 2 by 1 minus alpha by 2, then it is basically 1 upon fm minus 1 n minus 1 alpha by 2. Okay, so this value f at any degree of freedom alpha is equal to 1 upon f at same degree of freedom 1 minus alpha. So this is the rule. So if you just take this, let's say 1 upon f and this 1 upon a small f and 1 upon capital F, then f would be rejected when it would be less than f m minus 1 and minus 1 alpha by 2, right? So this would be its rejection region. So now we will move to the question here. So here we need to find these two variances are equal or not. So we need to find this variance for first and variance for second. So I think that you can calculate. So take your time and then calculate this. Like I will give you 5 minutes for that. So I think 5 minutes would be enough. So just find this variance of first one and variance of second one, and I will also find it. And in case you don't know how to use calculator, I can tell you right now. So do you know how to do this in calculator? Okay, so by phone also you can find, but then there is no technique further. Otherwise, you can use it in calculator. So I have found it. So you can take your time. So up to 9:10, I'm waiting. Otherwise, we will go on, and you can do it later on. Okay. Yeah. Okay. So, but I just want to tell you that it's better if you just do it, because if questions will come, then it will take time and you need to be prepared for that in the starting also. Okay, so h naught here is sigma 1 square is equal to sigma 2 square, and h1 here is sigma 1 square not equal to sigma 2 square, right? So now the S1 we have, S1 is the sample variance, is 9.395, and S2 F1 is 9.228, right? So F naught, this is statistics, so we need to find the statistics only, so that one would be S1 square divided by S2 square, because uh, in the calculator it just gives sigma x, so it would be 395 square divided by 9.228 square, right? So it is 1.036, so that would be answer, sorry, B. Okay, so next question given here is that we have two independent sample, and then it is coming from n mu comma 1 mu 1 comma 1, and then other one is n mu 2 comma 5. So this is xi and these are yi, right? So these, and then n is 10 for both. So then what would be the critical region? So critical region, you can take it as rejection region. Okay. So firstly, we can see this. This is what? This is two-tail test. So two-tail test, obviously again greater than uh, will come. Two-tail test. So alpha will come. Alpha by 2 will not come. So it would be either B or D. Okay. Now we will check what it would be. So Z we take as x bar minus y bar divided by uh, sigma 1 square by n plus sigma 2 square by n, right? So x bar minus y bar, and under root n is 10 for both, and sigma 1 square is this 1 here, 5. So it would be 1 plus 5. So 6 upon 10 would be 6 upon 10 would be what? 5 upon 3, right? So it would be 5. Here it would be 3 upon 5. So in total 5 upon 3 x bar minus y bar. So it would be root 5 upon 3 x bar minus y bar greater than z alpha. So that would be the answer, right? Okay. Okay, so the next question here is that, okay, so I think it is the similar question we have done till now. So you need to find, okay, so here in this question, no, this one. Okay, so this one you can see sigma 1 and sigma 2 was given, but here sigma 1 and sigma 2 is not given. So that you need to find. So the test is value of the test we need to find. So basically h naught we have is mu1 and mu2 are equal, and h1 is mu1 and mu2 are not equal. But here it is not given what is sigma 1 and sigma 2. So we need to find x1 bar, x2 bar, and then s1 square, s2 square, and n1 and n2 I think is same, and it is 1 2 3 4 5 6 7 8 9 10. So it is same 10, and yes. So the main thing at this point is degree of freedom. So new. So when it is 1, it is just new is what? T. 1. This n minus 1 alpha we say this is new. This is the degree of freedom, right? So when we take two sample, this degree of freedom is very important, and this the value. The formula for this is s1 is square by n1 plus s2 square by n2 whole square divided by s1 to the power 4 n1 square n1 minus 1 plus s2 to the power 4 divided by n2 square n2 minus 1, right? And then t statistic would be you can find this, sorry, you can find this t as this value x1 bar minus x2 bar divided by s1 square by n1 plus s2 square by n2, and then you can check this t statistic at alpha by 2 because this is two-tail test and alpha by 2 and add this new. So this is all calculation from here. Yeah, this is all calculation from here. So if time permits, we will do the calculation. Otherwise, you can just put the values here. You can find x1, x2, s1 square, s2 square, and everything is given. So you can do this, right? So this answer would be a value of a statistic, test statistic. So this statistic, and this value will give you the critical value. Okay, so critical value means the critical region value. Is it clear? hoping that it is clear. Yes or no? So I didn't hear you. If you are saying no, you can write here. I will see in the chat. If you are saying yes, you can. Then I'm considering it as yes if you're not messaging anything because your voice was not clear to me. Okay. So the next question here is that a random sample of size n from a population uh, with the with normal distribution is taken. So this is size n, and then it has population from a population n mu 1 comma to 25 has mean 20. Okay, so x bar you have given as 50, and that sample is taken from the population n mu 1 comma 225, right? Another sample of same size n is taken, right, and it has mean 45, and this is taken from n mu 2 to 25. Now in order to test h naught for mu 1 is equal to mu 2 and h1 is given here as that mu 1 not equal to mu 2, the maximum value of n so that h naught is accepted, right? So h naught is accepted maximum value and at 5% significance level. So when would be accepted it if our z mod z is less or equal to z alpha by 2. Okay, so uh, it is 1.96. It is very known, but in anyway, if you want to see this, you can go through this z table. Okay, so this need full table. This is negative. This is positive. Okay, so basically, when you have z alpha by 2, this is what point 0.025, right? So at that point, what we see is that uh, where is this? Because we are rejecting at this point, so we take this set table at where the value is 0.975. Okay, so this is 1.96 and this is 0.475. So if you have this value and this, so at this point, okay, so if we want to find this value, this would be the region. So z 0.025. Okay, so that means this value would have been crossed this just 1 minus, so it would be 0.975. So 0.975 at would come at this point. If you look at this 1.96, it is 0.475. So at 0, it is 0. So here it is where it is it? Yeah, 0.475. Then it means 0.475 plus zero point 0.5. So 0.475 plus zero point 0.5, it would be 0.975. If you see a value where, because generally the table is given in the form where 0, at 0 it is zero point 0.5, because at 0 it has already covered this area of zero point 0.5. Yeah, because of its symmetry, right? So at this point we check when the value is 0.975, so it is happening at z is equal to 1.96. So we take z value as 1.96. If it is not clear, I can repeat it again. Maybe there is the table is given as just do this. Yes, like you can see in this table, it is given the whole table from 95. So at 1.96, you can see 0.975 is the value. So 0.975 is value at this point. So this would be our z alpha by 2. So z alpha by 2. This is how we find z alpha by 2. So if you have any issue, I can repeat. Otherwise, we will move forward. Okay, so it is 1.96. Now, what we have here is that we can take it as y bar, so it would not be confusing. Okay, so z statistic would be accepted when it would be less than alpha by 2. Now, z statistic would be what? X bar minus y bar. So it is given as 50 minus 45. So it would be 5 divided by under root. Now sigma 1 sorry, sigma 1 square and sigma 2 square by n. So sigma 1 square is 225, sigma 2 square is also 225, and then n is also same. So then this is how we can write it, and it is accepted when this is less than 1.96. So H naught is accepted if this happens. So this is 15, root 15. You can now solve it. So it would be, I think, 50 minus 45, 5. This is 15. This would come under the root n upon 2, 1.96. So this is 3, right? So now you can see all the values are positive, so we can just remove this. Uh, so 1 under root n by 2 would be less than 1.96 times 3, and n would be less than 2 times this value 1.96 squared times 9, right? So ultimately it would be 18 times 1.96 square. So it is and less than 69.148, right? Now there are two values which are less than 69, 48, and 69. So the question is given maximum value of n so that h naught is accepted. So the maximum value of n would be 69, right? Otherwise, both the answers would be right, 48 and 69, because for both the answer it would be true, right? Okay. So we will move to the next question, which is x1, x2 up to x15 be a random sample from n, which is mu comma 15, and we need to test this mu is equal to 10. Mu is equal to 10 and k1 is mu not equal to 10, considering the critical regions. C is equal to x bar, where x bar minus 10 is greater than alpha. So we need to find the value of alpha so that the size of critical region is this 0.05. Okay. So now your xi's is random sample from n mu comma 15. Right. So the null hypothesis testing is mu is equal to 10 and k1 mu not equal to 10. Okay. So the critical region here is C x bar, and the okay, so better write it A, otherwise it would be confusing by alpha A. So then we need to find the value of A so that the size of the critical region is uh, 0.05. So the size is equal to 0.05. Okay. So the size or the alpha, whatsoever it is, maybe if you have attended the last class, I have told you this is alpha. So alpha is type 1 error. So type 1 error or alpha or size is what? Reject null hypothesis when null hypothesis is true. Okay, so this is alpha and you have beta. So at that point of time, we accept this h naught when h1 is true. So there are different things. So this is equal to the probability that rejecting null hypothesis when null hypothesis is true. So this is the rejection reason. So it would be probability uh, x bar minus 10 greater than a, and null hypothesis is true means mu is equal to 10. So mu is equal to 10 would be null hypothesis. Right. Now we need to find this. So z, firstly we need to convert it at z. So this is 15 is the variance, right? And mu we are taking at it as sorry, so mu we are testing it as 10. So it would be x bar minus 10 minus 10. So z mod z would be x bar minus 10, and then no, so z is greater than alpha, because in the time of 10 you take it would be just a minute, x bar minus 10 and then b minus 8a. You are taking mu as also 10 to b minus plus 10 minus 8, 10 plus 8, then you x bar minus 10 you will get to that minus 2. Okay, so that this is already your z, I think. So this is already your z, because z is nothing but x bar minus alpha. So x bar minus alpha, and mu is 10 already. So that would be your standard deviation. So probability that z is greater than alpha, and here its value is 0.05. So that you can do is that probability that mod z less than a, just remove this, would it would be 1 minus 0.05, right? And then that would be 0, sorry, 0.95. Or maybe it is sorry, it is because less than it is, sorry, one tail test, so you can take it 0.025 here only. So it would be 0.975, and we have just saw that at this point z comes as 1.96. So that would be the answer. So 1.96 would be the value of a. So here, if mu would be something else, it would be different. Otherwise, this is the z statistic itself, right? Okay, so there are one, two questions. I think no, yeah, here. So in this question, it would be clear, because here also it is 20, it is 20. So in, but in the next mu is changing, so that would be more clear to you when we do. So we can do this question firstly. It would be better. So so uh, basically the z statistic we have would be x bar minus 10 divided by sigma upon root 10. So z will be x bar minus 10 divided by sigma given here is 15, and n here is also 15. So sorry, sigma square is 15, so it would be root 15 divided by root 15. So z is x bar minus 10. So I think now it is more clear. So this is nothing but z, right? So this is the just similar question. You have value this, n is just different. So here xi is following normal mu comma 16, and n is also 16. So z here would be x bar minus mu as 20, and then it would be root 16. This is sigma divided by root n. So x is nothing but x bar minus 20. So now you can see this is the rejection region only. Okay. So if I write it in more explaining way, then C is what? X bar minus 20, t greater than or equal to alpha, right? So probability that this is mod z is greater than or equal to alpha is equal to what? Probability that z is less than or equal to minus alpha plus probability that z is greater than or equal to alpha, right? And these two probabilities are same. So then you can write it, this is 0.05 probability z greater than or equal to alpha. Is there any question or any joint? Okay. This is point 0.05, so it would be 0.025. Probability z greater than alpha. So 1 minus probability z less than or equal to alpha would be, so probability z less than or equal to alpha would be point zero 0.09, sorry, 0.975. Right? So if you want to do the step by step part, then you can do it like this. If you want to do that directly, then you can do as I have told you earlier. Now this, you can see this is the z directly, right? But in the next question it would be more clear. When mu is not 20, it is 30. So when it is 30, then rejected region would be different. So, and here we are finding the power of test. So power of test, I don't know whether you remember or not, but power of test is probability of uh, rejecting h naught given h1 is true, right? So h1 is true. So h1 is true means we take mu is equal to 30. In if h naught is true, then we take the mu is equal to 20. So h1 is true means mu is not equal to 20 and you have some specific mu is given. So at this point, rejection region, so reject h naught means the region is same, right? So mod of x bar minus 20 and h1 is true, okay, and greater than a given this mu is equal to 30 and this value is also given, a is equal to 1.96 is also given, right? So now it would be different. It would be what? X bar minus 20. So A is given, we are writing it like this, 1.96, and given mu is equal to 30. So now your X bar, you can write it like this. This is greater than, so it would be nothing but 1 minus probability mod X bar minus 20 less than 1.96 when mu is equal to 30, right? This is nothing but just probability that p is p of a is 1 minus p of a complement, right? So now it would be p minus 1.96 plus 20 to x bar 1.96 plus 20, right? And given mu is 30. So now we will make this x bar at as a standard normal variate. So x bar minus 30, and then standard normal variate would be what? Root under root 16 by 16, and this came from here because this is 16, so this is sigma square. Sigma would be root 16 and root n would also be 16, right? And this is 1, so nothing to do, and then minus 30 would be both side, so it would be basically 1 minus 10, and it would be 1.96 minus 10, right? So this is 1 minus p, and this is z, and it is in between minus 11.96 and it would be 8 point, think 0, 4, right? So minus. So now you know when the z table that is starts, the very z table is start from minus 3.4 or something. So basically this is 0 and up to 1 it covers 66% of the region, and in 2 it covers 95 most probably, and after that it covers 99. So in minus 3 to 3 it covers almost whole region. So if you have z value minus 11.96 to minus 8.4, so this comes under here somewhere, and its value will be almost 0. So then it would be 1 minus 0, it would be 1. So power of test is 1. So this is the answer. Now you have any confusion regarding this question or the previous question we have solved, then you can ask. Okay. Okay, so it is okay. So we will move to the next question. Okay. So the next question given here is a research claims that at least 15% of all football helmets contain manufacturing faults. Okay, so there is fault in all the instrument or whatsoever we use, uh, like normal helmets or various kind. So it is given here is that at least 15% have faults, and it would obviously result in damage. So we cannot consider these helmets, right? So 20 helmets we are taking out of a sample of 200 container, uh, out of a sample contain these flaws. So we are taking a container, we are just taking a sample 220 are faulted. So we need to find the value of test statistic to claim the researcher, right? So now we can take h naught is a 15%, so we can take p is equal to 0.15, and h1 we can take p is not equal to 0.15, right? Okay, so now this one n here is 200 and x here is 20. So uh, the p naught we have found here is 20 divided by 200, right? So it would be, okay, it would be point 0.1 I think, right? So now we can find z statistics. So we can do it as x minus np naught divided by under root n p naught and q naught. So as you can consider it as a binomial, and then you have np and npq as mean and variance. So this is 20 and np naught, so 0.15 times 200 would be uh, 30, right? It would be 30 divided by uh, 30, and q is 1 minus p, so it would be 0.75, right? So it would be 10 divided by some value, so sorry, minus 10 divided by some value, and this value is, so it is minus 10 divided by under root 30 into 0.75, which is, okay, no, sorry, this is 0.15, so it would be 0.85, not 75. So it is minus 1.98. Okay. So that was needed to find out. So that would be the answer, minus 1.98. So I hope it is clear. Moving to the next question. So, all right. So what is given here is that sigma is square. So we are testing variance. Sigma square is equal to 4, and given is sigma square not equal to 4. uh, and then we want to do this, then asymptotic critical region for of size alpha for this test. Okay, so this is the test we considered. So in the time of sigma square, so, what we have seen is that we generally consider this test of uh, chi-square, but sometimes like answer is not given in the term of chi-square. So there is another test which is known as average sample test for the variance. So I'm writing it here. Okay, so it is average sample test for variance. So the chi-square. Okay, so what do we consider here is that s is approximately, we say that if you have xi from I to n obviously, and this is coming from this population, this sigma square, then we say if when n is large, then we do approximation like this, and then we say z is equal to under root 2n s minus sigma naught divided by sigma naught. This would follow and follow and then we reject the and this n is 0 1 standard normal variate, and then we have this null hypothesis. Sigma square is equal to, sorry, sigma square is equal to sigma naught square, and h1 as sigma square is sigma naught square. Then we reject this h naught if mod z is greater than or equal to z alpha by 2, right? So this is the test statistic. So we will move to the question. Right. This was the question. So test statistic would be what? Uh, S minus sigma naught divided by sigma naught, and then under root n. So it would be n is 10, so it would be 20 s minus, and then since we are dealing with this we need to find sigma square, then we will do this for 4, like sigma square we will subtract, otherwise that test was for sigma I think. So for sigma square, if you are testing for this sigma square, then we take sigma naught square, right? So this would be the test. So under root 20 s minus 4, and then the rejection region would be what? Sorry, the rejection region. As I have said earlier, that when you have not equal to, the rejection region will always be greater than or equal to alpha by 2. So this would be the answer, right? So the next question, I think we have just done similar question, so you can try this. So here xi follows n mu 1 and yi follows n mu 2, and then for the hypothesis of h1, mu 1 is equal to mu 2 and h2, sorry, k1 mu1 not equal to mu2. You need to find a size alpha critical region, and what would it be? So firstly, it is equal to n not equal to, so the region would be alpha by 2, because this is two tail test. So the answer would be A or C. Now you can calculate value, and then you tell me what would it be, whether it would be A or C. So this is a two sample problem, and for two sample problem, the formula is x bar minus y bar divided by sigma 1 square by n1 plus sigma 2 square by n2. Okay, so it's I think it's very simple. You need to remember this x bar minus y bar divided by sigma n is same. Sorry, so sigma 1 square is 1 upon n is 1 by 10. This is 2 by 10, so it is 3 by 10. Overall, it will be under root 10 by 3. So 10 by 3 x bar minus y bar. This would be the answer, right? Because 2 days, so it would be Z alpha by 2. So we have solved this, and this we have next question. Okay, so this is 12. Okay, so So two new trick A and B are tested on the set X and Y of the patients, and a random a sample of 12 patients from the set on which drug A is tested, and this is for B, right? So following is the observation. X bar is 28, S1 is 5.88, and N2 is this, and Y bar is 30, and S2 is 10.04, right? And so for the testing equality of means, so equality of means we need to check. So again, the question is the same, whether mu1 is equal to mu2, and whether this mu1 not equal to mu2. So Z statistic would be what? We need to find the statistic only. So it would be X bar minus Y bar divided by S1 is square, so 5.88 is square upon N1. N1 is 12. Yeah, you have anything to say? That would be test statistic, and that we can calculate. If you have anything to say, I'm sorry I'm unable to hear you, so you can write in the message. 88 is square divided by 12 plus 0.04 square, and this is divided by 15, so it is 0.64. This is coming as 0.64 around, so this is the nearest value. This will be the answer. Okay, so this is up for the today's class, and next class we have on Thursday, just day after tomorrow, and that would be the last class, last problem solving session. So if you have any doubt regarding the questions, like from the first class to up to this, then you can ask in the next class. Otherwise, I will uh, have some questions regarding this hypothesis only, and this like how you can understand, and there are some questions regarding this estimator. But if you feel you have any issue, you can either tell me now that I need to cover this topic also and questions of that topic, so that I can write now, or otherwise I will have some questions from my side, and then in the class you can just ask if you have any doubt regarding this whole course, because that would be the last problem solving session. Okay, so thank you. And if you have any doubt, you can ask me. And otherwise, I'm gonna just end the class. So I'm waiting 1 minute. If you have any doubt, you can ask me. And other advice you can write. Pritham, I cannot hear you. I'm sorry you are unmute, but I cannot hear you. So you can write in the message. Okay. I don't know actually, that you need to ask from the NPTELs. I'm just from the for the problem solving session. I have literally no idea regarding your exams, so that you can mail to NPTEL itself, or maybe you can write in the discussion form. Maybe they will give you some answer. If there is nothing else, then thank you for joining this class, and we will meet in the next class on Thursday. Review of full course in the, yeah, of course I will go through that. So from the very starting, like very starting, what is what was means what is discrete and then continuous, then there are different distributions, so that we can just go through so that you will remember these all things. And then you have joint distribution, and after that sampling, and then you have estimators, different kind of estimator, and then ways of finding these estimator. And at last, I think this is this hypothesis testing. So we will have some questions regarding these testings, and then otherwise we will go through this course. Okay, so I think that's it for the today. Thank you. So, okay, cool. Thank you.